I was putting down some dates up on the board for people to pay attention to. Hi. And so here are the due dates as they stand in your life in this class, in blue and white. Assignment 1 is due October 24th by end of day, 11:59. Blackworth candle vano retentive. Therefore, give yourself an extra minute. So assume it's due at 11:58. If you have a little glitch in your internet, you might have some problems. If you don't hand it in by that time, automatic 10% penalty. End of story. Do not pass go. Don't ask me for not, because you've had lots of time to work on it. Hybrids. November 21st. You'll want to do hybrids 4 through 7. It's 4, and there's 4 weeks. It should work. Why? Because test 2 is on November 21st. That's probably the other one you guys care about. And make sure you don't miss the test. Because I did reopen it and I took a penalty off whoever redid it. And at this point in time, probably not going to be reopening it because now you can ask someone else for their answers because I'm about to hit the switch. So you can see your answers and what you did do and did not do well. All right. This week's lab is lab 6. That should take care of all the administrative minutiae. And I'm going to start going on with today's lecture as soon as I move my camera back to point in the right direction. That's crooked. This and this. There we go. This from the beginning. There we go. Don't pay attention to the date. It's a standard slide. I probably should be week 5. It's been covered at week 4. It's been covered at week 5. It changes from term to term, but it's a week 4. What are we learning today? You'll be glad to know there's a slight change in focus. Guys, less lip flapping, more listening. Because if you're talking, the people behind you can't hear me. Thank you. What are we, grade 2? Now, this is a change of topic. The design theory stuff is pretty much done. Okay, we've crossed off our T's and dotted our I's. We've covered the material. That's probably about 60% of the written exam. So, just so you know, theoretically, if you got 100% on everything you covered so far, not in the course, but if you were to write the exam tomorrow, and you got 100%, you could get a 60% on the exam. Theoretically, from the version of the exam I've seen so far. Although there's a whole swath of questions still missing, so I don't know. We're going to go with it. So what we're starting today is learn how to communicate with the database directly. You're going to learn a new programming language. Yay, languages. You're going to learn about SQL. And I'm actually going to skip a couple of slides at the start of the slideshow because originally I was planning to cover an extra piece of material, but there won't be enough time this term. I just didn't update my slides. Okay. We're going to talk about SQL. SQL is an old language. It's been around for a long time. It's what they call a special purpose language. It's designed to do one thing and normally try to do it well. It was created by IBM in the early 70s. And it's an odd language. Originally it was called SQL, literally like SEQUEL, Structured English Query Language. Therefore, this is where the whole history of calling it SQL came up. So you'll hear somebody say, I learned SQL. Okay, no. They had to change it to SQL because they were taking a quarter of a copyright infringement on the name. Because another company had a product called SQL and had to do with databases also. So IBM actually lost a lawsuit. You don't hear that one very often. So essentially, IBM came up with a product called the SQL. It became called SQL. It's an initialism. That means it's SQL. You don't pronounce it SQL. The first commercial version of SQL showed up on Oracle, version 2, for the VAX computer. Most of you don't know what a VAX computer is. A VAX computer was a computer that was about twice the size of this desk. And it was impossible to break. Probably the most robust micro PC ever created. Microcomputer, not micro PC. But Oracle was the first one to bring SQL. It was really limited. Had set number of features. It didn't do a whole lot, but it did one thing. It standardized talking to the database server. In 1986, the ANSI group, which I'm sure you guys have heard the phrase ANSI before, ANSI characters, ANSI standards, various plugs. USB is ANSI standard. It's a standardization group, and they said, we're going to start standardizing the SQL language. So they came up with a standard called SQL86. Right now, I think we're sitting at SQL 2009. It comes out with an update every 3-4 years with some extra features that nobody implements. There are features that get implemented from each revision, but each database server and product chooses to implement what pieces they want that fits their strategic vision. If they actually implemented everything they recommended, they'd be totally unusable. The 1999 standard, which is also known as SQL 99, brought in some major changes. The original one, you could do queries, you could do updates, they had joins, sort of. In 99, they brought in some really big things, and I got a typo. That should be regex, not regexm. That's supposed to be a comma. Regular expressions were brought in, so you could search using regular expressions. Recursion triggers, when triggers are finally formalized. 2003 and 2006 brought in support for XML, because XML was the shit at that point in time, and still shit today. Just during the word duck is gone. In 2009, they brought in something called instead of, an official 2008, brought in a command called instead of. So you can write a chunk of code, and if an update command gets issued, you can tell it do this instead and ignore the actual real commands. You can actually override functionality of the database server completely. It also formalized the concept of truncate. Truncate school, I'll talk to you guys about that later. It is the absolute best destruction tool ever. And apparently, according to my slide, the current standard is 2011. I guess I must have researched that when I updated these slides last spring. Most database servers are running at around SQL 99, plus select features from 2006 and 2008. All right. The SQL language itself is an odd language. It's very English, as in it uses English words. None of this cute little for loop syntax and this weird if syntax. Normally with a lot of SQL statements, especially with the DML portions of it, which I'll discuss in a minute, tends to be, you can actually read it as a sentence. So if you read it out loud and it makes sense, it's probably going to work. Whether it does what you want it to do or not, that's, like any programming language, a computer will do exactly what you told it to do, not always what you want it to do. So SQL is made up of 3 pieces. There's the DDL, the data definition language. It's what you use to create and maintain the structure of the database. This is the bit that creates the tables and updates the tables, and adds views, and all kinds of other stuff. There's the DML. That's the portion of the language you use to interact with the database, to add data, remove data, identify data, summarize, that kind of stuff. It's essentially, when you have a web app and you go to a web page and it pulls out a list of, go to Amazon, it shows you everything you searched for. Amazon's a bad example because they don't use SQL anymore. But or here at the college, you go look up the list of books available at the school store. It's coming out of an SQL database. They run a query. Poof. That's what SQL is for. But there's also the DCL, which is the data control language. Its purpose is to control the security of the database. This course touches on it almost not at all, for a couple of reasons. One, it tends to be very implementation specific. In other words, Oracle's commands are sort of like Postgres's, but not quite. And they're sort of like MySQL's, but not quite. And then you got Microsoft, who ignores it outright, because they give you a graphical UI. This usually gets to do this, 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 and this. Click, 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 click. Because it's graphical. So we don't really touch on the DCL very much other than to quickly discuss what it does, and that's it. Most of this next 3 weeks will be focusing on the DML, mostly. 3.5 weeks will be the DML. But today I'm going to talk about the DDL. For those of you that already started doing Lab 6, you've been messing with the DDL. The language is case insensitive. Now we got to be careful here when I say case insensitive. The SQL keywords themselves are case insensitive. Object names, depending on the database server, may or may not be case sensitive. So you should start getting into the habit of assuming it's case sensitive. Postgres is very, very case sensitive. Microsoft SQL Server depends what region you install it in. If it's installed on a Cyrillic server, it's case sensitive. If it's installed in a Latin, whatever, North American setup, it's not case sensitive. Oracle is not case sensitive because it's special that way. It gets clever and hides the fact from you that it's lying about your object names. You give it a mixed case object name, it makes everything uppercase and stores it that way in the database. That's just how Oracle works. You've got a few others that are different. Their behavior is different. MySQL may or may not be, depending how you installed it. So case sensitivity, assume object names are case sensitive. Obviously, they're case sensitive in Java. Therefore, by now, your brains understand the concept of case sensitive variables. Therefore, fields and table names are case sensitive. Just assume it is. The data is normally case sensitive unless you're using MySQL. Then it's not case sensitive because it's MySQL. It uses spaces as keyword delimiters. This is like C, sort of, and Java. Sometimes you have to put spaces between certain keywords and sometimes you don't. You know, new space, whatever variable name has, new string kind of thing. You need spaces between keywords at certain places. With SQL, there's spaces everywhere. Which brings me back to the naming conventions. This is why you don't put spaces in your object names. Because SQL will see that as two things, not one. The command terminator is a semicolon. Why? Somebody thought it was a good idea, therefore they stuck to it. You guys should know about semicolons at the end of your commands. Congratulations, you don't need to change your brain there. By the same token, there is a small thing to say on that. If you are running only one SQL command, it doesn't need the semicolon. If you're going to run multiple commands, it needs semicolons so it knows that there's more than one command. That's, sometimes you'll see me type up commands and I don't put the semicolon. It's because I'm running one command. I should get into the habit of putting a semicolon, but I just forget. All right. First things first, the DDL. That's pretty much what I'm going to focus on today. The DDL is made up of 3 commands. And I'm going to make sure I put the slideshow up because there's links in the slideshow. The first one is create. You use this to create objects. In other words, you're going to create a table, create a view, create a trigger. There's a syntax that follows it. And it's, a little weird. It doesn't look like anything you guys have ever worked with. There's the alter command. It lets you change the stuff you just created. You want to add a field, take out a field, rename a table. You use the alter command because you want to alter it. You want to change it. And then there's drop. In other words, you want to get rid of it. Drop is very destructive. You issue a drop command, and your data is gone. Almost instantly. The system does not care at all. I'm going to mute my phone. And so when you drop a table, things go away. All right. The basic syntax for the create, and I should have loaded my SQL editor in a moment, but I forgot to, but I'll do that in a second. You use it to create database objects. Essentially, the syntax is you want to create what with its name and then its definition. The definition syntax depends on what's being created. The SQL language is weird that way. It looks like essentially they had a bunch of software engineers sit in separate rooms and not communicate. And everybody wrote their own little piece the way they wanted it. And, you know, as we go through this, you'll see like some of the syntax is totally different from one thing to the other. The hardest part of SQL is memorizing the structure. But the good news is, you know, Google's only, you know, 2 clicks away. But for example, the most common use of create is to create tables. And you can see here on the screen, I've got a table, I created a table called test. I've got an ID, a name, and an active. This should look a little bit familiar from lab 4. You know, when you're exporting that script and running it, it looked something like this. And in lab 6, it looks almost just like that. When you create tables, that's basically the syntax you're going to use. The link in there shows a link to Postgres creates the table syntax. And just so you know, the syntax is actually really impressively long. You don't need to memorize all that, obviously. It basically every single combination of what you can do with a table is in there. But they've got really good examples in this that explains how all of it works. And usually there's even short little examples somewhere. Usually somewhere. As you can see, Postgres' documentation is very extensive. All that just to come up with this. And it shows you all the bits and pieces that you can create. And in just a moment, I'll actually do a quick demo. I'll be demoing as I go. Almost there. There we go. Okay. Do this. And essentially what I'm going to do is I'm going to do a create table command for you guys. Typing blind because I can't see on the screen in front of me what I'm doing behind me. Let's go. So, I'll make it a little bigger. Not this way. All right, so create table. So in other words, I want to create a table. So you're going to say create table. You have to give it a name. Let's go with users. This should look familiar so far. So essentially what I'm saying is I want to create a table called users. Now the definition for a table is contained in brackets. And as a habit, you should just start opening and closing your brackets right off the bat so that you don't forget the other half. It would suck if you forgot the other half. And in here, we're going to create our different attributes / fields. And this is going to be a big serial. You guys should recognize that data type from what we were doing in the labs. And it's going to be a primary key, like such. I'm going to create one called name. That's going to be a varchar 50, not null. That means that that's required. Password. That's going to be another varchar 50. I can type. Such. Oops, missed my bracket. Then we can go email, and we want to do a varchar 150, like such, and we're going to go active. That's a Boolean default to true. Essentially, that's exactly what you guys are doing with Toad. When you're creating each of the fields and picking up all the things. When you hit the create script button in Toad, it's literally just typing this in for you. On my day-to-day job, I usually have about a 50% chance I can use the diagram and a 50% chance I can't. Why? The two of the databases that I use at work are so big that the diagrams are unusable. Last time I printed one, it was on a 4-foot wide printer and it was a 6-foot long printer. So 24 square feet of ink and paper. to represent a database with 300 tables in it. It was excessive. So I'm going to run this and hope I got it right. I don't see any underlines. And it worked. So in theory, if I were to go, and there'll be no data, I'll talk about this command and then right at the end today. Go. It's an empty table, but you can see the structures there. The table created it. That's great. Okay. Come back here. I'm going to go back to standing, back to PowerPoint. All right. So that's the create table syntax. You can also use it to create views, and the syntax is, you guys are going to learn about views later, but essentially the syntax is completely different from creating a table. Go figure. As is creating a trigger or creating an index. Those you'll be learning that stuff also later, but for now you need to know how to create tables because that's what Lab 6 is. Therefore, it's kind of important to know how to do it. All right, the next command you'll see is alter. Alter is used to change the structure of the table or of a view, or you want to replace a trigger or a function or something. And essentially, the syntax, I'll be putting up an example because I'll be adding a field and renaming a field on that table I just created. You can use it to rename columns, remove columns, add columns, set some syntax, some defaults, that kind of stuff. And again, the syntax depends on each kind of object you're working on. There's a link on that slide. As you can see, the syntax is completely different. That's just the alter table. And then if you went and did, there's other alters in there also. There's alter view and alter other objects. Alter tables, which you can use 95% of the time. And I'm going to do a quick on-screen demo. So, back over here. So we had our table that we created, right? And let's ignore me completely. There we go. Why my keyboard's not very nice. Okay, alter table, and I called it users, and I want add a column. And you give it a name. Oh, what can I add to my user? I'll call it access level, and I'm going to call it, it's going to be a big int because it refers to another table. For now I don't have another table, so I'll leave it like that. Default 1, and I'm going to hit run and hope I got it right, and bam. So that's how you add a column. If I wanted to rename a column, you want to go so make there we go. So let's say I decided I didn't want to call it. I remember I created access level, and I'm saying, well, it's supposed to refer to another one. Well, I made a mistake, right? Because it shouldn't be. It should be called alter column. What am I doing? It's rename. Like that. So that's how you'd rename a column. You just say rename column, original name to the new destination name. And I ran it. Now I just ran it the second time. It's giving me an error message because the original one doesn't exist anymore. So if I were to go You'll see down here now I've got an access level ID. Originally was access level. Now the last bit is drop. Actual fact, I'm going to go back to altering the table just a minute before I do the demo of the drop. But drop is the easiest one to remember because the syntax is really basic. Drop whatever kind of object it is, and then you give it the name and gone. It's over. There's no extra parameters, except when you have referential integrity rules. So you know when you draw the relationships between objects and it creates the references commands between them, you can't drop a parent object if there's something that's relying on it, unless you do something I mentioned before called a cascade. And if you do a drop cascade, the parent goes and it takes all the children with it. And if you got the children have children and the children have children, you're nuking the entire family tree. It's just going to be gone. So you got to be careful with the drop command because bad things can happen to you or to your data. And normally if something bad happens to your data, something bad happened to you also. You're probably looking for new employment. Unless you're able to fake why it went wrong. I'm not saying I've ever done that. So, let's say I decided I didn't want the access level ID on here. There's one more command I wanted to show you in here, and I just forgot. You can go drop column, like that, and then the column will be gone. That's I don't know how to type. Gone. So now if I were to go back to show you guys down here, you can see now the column is gone. But let's just say I wanted to be extra aggressive. I can go drop table users. As you can see, there's no extra parameters. Gone. Table no longer exists. If I ask it to retrieve data from that table, as you can see, it's gone. There is no data there. It's pretty self-contained and pretty destructive. All right. Now those are actually basically the three major commands you'd use in the DDL, and the slideshow is not coming up. There we go. That's the end of the DDL. Essentially, that's the big, long and short of it. The most important part is you realize you have to go look up at the syntax. There's so much syntax that I could spend an entire month just teaching about create table. And how much of that syntax would you actually use out in the wild? What I showed you today in 5 minutes. So there's no point covering extra stuff that you're never going to use. The next part is the DML. And the DML is made up of five commands. The first one is insert, lets you add data. The second one is update, lets you change the data. Delete lets you delete data. And then the select lets you pull out data. As you saw me running select statements earlier to show you the table structure. And then there's truncate. Truncate's cool. Truncate is evil. Truncate is like taking a chainsaw to cut a piece of bread. It's special. And of course, every command has a different syntax. Why? Because all the pocket protectors in the 70s were sitting in separate rooms. And they all thought they knew best, so they all created different syntax. I'm sure there's, over the years, a few different database products have tried to standardize the syntax of some of these commands. MySQL has weird syntax that allows you to do an insert, like an update. It's gross. All right, the insert statement. The command was created to add data to a database. And at first when you start learning SQL, a lot of people use the command create to create data. Now create is to create an object. You insert data into a table. It's sort of like if you have a file folder, you're inserting a sheet of paper into a file folder, as opposed to you are creating a sheet of paper. Poof, paper appears. I wish I could do magic tricks. You know, poof, paper appears, and then you put it in the file folder. That's what create would do. Insert is to add data into your file folder, thus you're adding data into your table. The syntax is as follows. Insert into whatever you want to insert. So we have a table called test. You insert into test. You give it a name. You give it the list of the fields you want to populate. Because when you add data to a table, you don't have to add all the fields in. You only have to add the ones that are not null. Therefore, you can actually add data in with pieces missing, and that's okay. And then you tell the list of values. There's a link on the slide for the insert, and I'll do a quick demo of the insert. I guess I should recreate my table, eh? Boom. All right. Which one's this? We're not, no, just the name, right? Okay. All right, here's a few things that you need to be aware of, and I got a typo. Okay. As you can see, that's a string field. All right, it's a varchar. Single quotes. Depending on the database server, some allow you to use double quotes, some of them allow you to use single quotes. Postgres cares. Lots. Single quotes. Not double quotes. Postgres uses double quotes as object identifiers. In other words, you were that special child that created a mixed case table with spaces in it. You got to wrap it in quote marks. Anybody here played in DOS recently? You guys taking Linux yet? No, next term. When you open up a command prompt, especially in Windows, and you go to any path that has a space in it, you have to put quotes around it so it knows that there's a space in the name of the file or the path. SQL is the same way. You have to tell it's an object. The problem is different database servers use different identifiers. Postgres uses double quotes. Microsoft products use square brackets. MySQL uses backticks. The only time I've ever seen a backtick ever be used for anything. If you don't know what the backtick is, it's the one that's under the tilde. If you don't know where the tilde is, it's under your escape key, because it's probably a key you almost touch maybe once a year. It's approximately correct, right? Tilde. And now people are going, yeah, wow, I never touched that key. That's totally shiny, never used. Actually, on my laptop, it's like the smallest key because it's so unimportant. It's not even the width of my pinky. And every other key is full size. All right, so I'm going to insert that value. And I got a bracket. Because it's not select dumbass, it's insert. Let's try that again. Insert. Bang, it succeeded. Yay for Dan. It worked. Now, earlier I said, well, you know, a maiden name required. I'll show you guys what the error messages look like. Yeah, I go insert just straight up email. There you go. That. And I go run. You'll see down here, and of course I can't make the error messages any bigger, but you'll see null value in column user violates not null constraint. I'll give you 3 guesses what that means. If you see a line that says such a field violates not null, it means give it a value. And Postgres is even nice enough to tell you which field you didn't fill in. But SQL is weird. It's a bit like you fix the first error, then it'll tell you about the next error. It doesn't tell you about all the errors, it tells you about the first one that killed it off. So sometimes you have to keep going over and over and over again and just keep reading the error messages until you get it all right. So if I change this to be like this, and I call this that, and I go run, now this will let me go. I insert it into two fields. I'll put an active. Now, if you guys remember, active is a Boolean. That means it accepts the word true. Or it'll also accept T or F in quotes. That's just Postgres being nice to you. But it'll take true or false. And true is not case sensitive. And I'm going to run that. And I think that worked. Shoot, that's what I wanted. And there's all my little inserts that I was running a minute ago. And you can see me choosing to populate certain fields or not populate certain fields. The first time I did the first insert, I didn't include the active field, but it already defaulted to true because when I created the table, I made it true by default. This shows how the default behavior acts. I'm sure those text messages are really cool, guys. You're sure to get distracted. See, they're not even listening. I'm sure your girlfriend loves your messages, but stop playing with your phone. Because if it's distracting me and I'm losing my train of thought, because you guys go like grade 10ers that got their first girlfriend? Yeah, stop that. Yeah, same difference. It's still rude. It's still rude. All right, update. You use update to change the data you have in the database. And this, as I said earlier, this syntax is completely different from what you saw in the insert. It would make sense if they follow the same syntax as insert. You'd only need to learn one syntax with two keyword difference. The update acts a little different. The syntax is update a table name. You set field equal value. In other words, you can do it as key pair values. Did you guys learn about key pair values yet in Java? This is a lot easier to explain to people that have taken this. Key pair values means field name equals value. So it's sort of like variable is equal to value. And in this case, if you want to set more than one field to a value, you can just comment the limit. Field equals value, comma, field equals value, comma, field equals value. I'll be doing a demo in just a moment. I'll do the syntax with the delete so I can sit down and do them all in one go. Because the syntax for the delete and the update is similar. You delete from whatever table, where you feed it a condition and data disappears. If there's referential integrity involved, such as a parent-child relationship, you can't delete a parent if it's referred to from a child table, unless you set the rules accordingly. You remember in the diagram I had you guys set, on parent delete cascade? When you create those relationships, if you delete from the parent, it mutes the kids automatically. It's like family genocide. No questions asked. Gone. Everything's gone. It doesn't warn you. And I'll show you guys by what I mean there's no warning right about now. This guy. All right, so I've got some records in here. I'm going to go update users, set password. Okay, so first thing I'm going to do is I'm going to run this command. This is a function called MD5. It's a hash. Don't worry about this part. I'm just showing you guys how the syntax works. And I got an error. Yeah, I am. There we go. Try that again. Bang, 3 rows affected. As you can see down here, what I just did is I set everything the same hashed up password. That's why you have to be careful with the update command. As you can see, you hit the run button. Did it ask me whether I wanted to do that or not? No. And it never will ask you if you want to do that. Unlike Windows, when you select a file and you go delete, and it says you want to delete this or not, SQL doesn't ask you. And the other catch about SQL is it's instant and it's permanent. There is no undo. Oracle sort of has undo, if you type in this cryptic set of commands first. So, if you want to do it safely, let's go. Like such, where ID is equal to 2. What that's going to do is it's going to target a specific row. And this brings back that whole, why is the primary key important? I'll give you a guess why the primary key is important. You can identify one row specifically by its ID. Now imagine if we had a multi-part primary key, which is something I've told you guys to please don't do, because it's a bad idea. You're not going to have a good time. Let's say it was a 3-field primary key, a bit like in that normalization exercise. Because it was a really terrible table structure, but you could, for updating, say the hours worked in the second one, you'd have to target the NIN and the contract number, or the NIN and the hotel, to be able to update the hours worked, because you have to have a 2-part key. In this case, it's a single part key, so once I run this, it should show 0 is affected.
Because it's 82.
There's no 82?
82.
Eh?
1, 3, and 4.
Oh, is that right?
Yeah.
I didn't notice. There, 1 row affected. Now, with 1 row affected, that means if I go select everything from in here, yeah, 1, 3, and 4. It's at the bottom here, this one I just created. You'll notice now that the rows are coming out in a different order than they were originally. Originally it was 1, 3, 4, now they're coming out in 1, 4, 3. And that's a Postgres quirk. It's the way Postgres writes its data. What it does is it'll take the new record, it'll actually write it to the end of the table. Once it knows for a fact the write was successful, then it marks the old one as deleted. That way what happens is, if something goes wrong while it's writing the new record, it can always just roll back and say, dude, it didn't work, but good news, we didn't lose anything. It's just its way of making sure you don't damage your stuff. And if we do, and I'm typing and I don't know where I'm typing. Heck. Now, if I did delete from users, like such, what would happen?
The whole table is gone.
They'd empty out the whole table. It's a good and bad thing. It's very destructive, but I'm going to delete just the 1 for now. Now you can see blank 12 milliseconds. That's pretty quick. Now, earlier I discussed the word truncate, the command truncate. That's the half command. Oh, shoot. Back over here. Truncate is special. Truncate was added fairly recently compared to the other commands in SQL. And essentially its purpose in life is to allow you to do a delete from table where without the where. So you notice I go delete from users semicolon. It's designed to be a high performance version of that. So for example, when you look at a database, for example, we got ID and name. So we have 4 rows of data. And if I go to delete one, what actually happens is, depending on the database server, the delete behavior behind the scenes is different. There once was a time actually it still is like this. In Windows, when you delete a file, do you know what actually happens to the file? It doesn't actually get deleted. What happens, it reaches into the file allocation table, which was on DOS, the FAT, or in Windows 10, Windows 8, there's something called the MFT. And essentially this is a big giant catalog that tells the computer where all the files are on the disk. And what happens is you delete a file, what it does, it doesn't actually delete the file, it just says, it reaches into that allocation table and says, this space is now available. And the data's still there. That's why it's so easy to recover somebody's bad pictures. It's like, I had to recover a drive at work last week. It took me about 5 minutes to recover half the disk by just running a please don't delete this tool. The database server does something similar. What you don't see inside of it and I'm super simplifying here, okay, just saying. It marks the record as deleted. It's not actually gone. It actually says, oh, I deleted Bob. So what happens the next time you go ask for all the records, it pretends Bob does not exist. Sounds fair? Now let's imagine this table had 10 million rows. And you do delete from users, and there's 10 million users. It will literally go user 1, delete, user 2, delete, user 4, delete, 1 million times. It's slow. Somebody said, yeah, but maybe we want to empty out an entire table. We want to make it happen fast. Somebody got clever, and they created something called truncate. And truncate is a half command. It's half DDL, half DML. I know it sounds weird when I say it that way, but what it actually does is, depending on the database engine, it actually modifies the table structure. In Postgres, what it does, it goes and essentially says, that. It doesn't mark each record as deleted. What it does, it looks at the commands to create the table. It temporarily unlocks any connections, drops the table, and recreates it. In other words, it literally deletes the file right off the disk and then rewrites it in the same place. That means that the truncate, basically, it's as if you took a pair of scissors and you just cut the bottom off page of paper. Gone. Data's gone. In MySQL, it does some other little magic things, just so you know. If you're using an auto increment field, similar to the big serial, behavior is a bit different. It actually resets it to 1. So it's like it never had any data put into it at all. It's like a brand new virgin table. Nothing ever happened when you truncate. It's pretty cool. Often I get students ask me, well, why would you want to use truncate as opposed to delete? If you need to empty out a table fast, you do a truncate. If you're using it, for example, to load data as a temporary holding bin, you load up an Excel file, you insert it into this temporary table, and then you use that data to build up the rest of your data in different tables. You take the non-normalized data and you shove it into a nice normalized database. You'd use the truncate to purge that table so that it's always clean, so you don't keep carrying in old data. And the truncate is usually 90% faster than a delete. But it's dangerous.
I have a question.
Yes.
How big does the table have to be to use truncate? I mean, compared to delete.
Well, for performance reasons?
Right, yeah.
Depends on the hardware.
Okay.
I mean, I've done a delete from some table that had 1,000 rows and it still just would blink.
Oh, okay.
The truncate just would blink faster. Really, what you want to do, though, is you're using truncate for performance reasons. essentially, if you know this table may get big at some point in time, or you want to make sure it's completely clean, you'd use truncate. It's sort of like you're vacuuming
Yeah.
the database. Okay. The select statement is the last one. As you notice, I didn't put a link. Because what's going to happen is the next 2 weeks is just going to be select statement. There's so much to it. That's where 90%, 95% of your database work when you're programming, that's where most of it's going to be. You might spend a week defining your database structure, a day or two inserting data, and then you're going to spend a year writing code that retrieves data out of the database. SQL is really powerful in its own way, and it has an insane amount of syntax when it comes to the SQL statement. But the most basic command is this one. Select star from whatever table name. This is the SQL version of Hello World. Essentially, that's the first command they always get you to run. Is select star from insert whatever table they have as an example. That they have as an example. Honestly, there's not much to say past that. I'm going to actually start diving a little bit into the SQL, into the select statement. But I'm going to let you guys have a 10-minute break. And then the attendance word will be up on the board when you come back. Yeah?
Quick question between delete and truncate, because when you delete, you say it's technically still there, it's just checked off.
It's been deallocated. The space has been reallocated.
Truncate, is it like still technically like a bit of it there?
Well, you could theoretically use a disk retrieval tool to pull it out, but the server cannot recover it, ever.
So if it becomes too big and those become like too like built up in it, can you truncate them?
Well, no, what truncate does is it starts rewriting in the same space on the disk. Delete just keeps appending at the end. So let's say you had 1,000 rows, and you delete everything and you start inserting, it's going to start allocating space at the end of 1,000 rows, whereas truncate starts rewriting at the beginning. All right, here we are for round 2. I'm actually not going to get through this whole slideshow. I want to get through about half of it today. Thank you. All right, I'm going to continue with the select statement. Because like I said, that's where you're going to spend the majority of your time interacting with the database, is using select statements. It's used to retrieve records from a database, as you witnessed earlier. It's a very, very flexible command set. Unlike some of the languages you guys are used to where, for example, in Java, you write a series of commands, and then you hit run, and it blows up, and then you fix it. It blows up again, then you fix it, and it runs. SQL is essentially one command. In other words, you run one command. Then you run another command. And a third command. So for example, each command, and I'm being a little cagey here, it's not quite the truth, but we'll say it is. Each command is atomic. You run command A. When you run command B, it knows nothing about command A. So there's no carry forward from one command to the other command. So that's what I'm saying. You run one command at a time. End of story. There isn't 3 or 4 commands. You run one command. At least at this point when you're interacting using the SQL statement. It's made up of, as you can see, 2, 3, 4, well actually 6 or 7 parts. Depending on just what feature set you need to use, you don't need to use all the bits and pieces of the command. I'm going to ask another question. You guys have learned about functions, right? I hope. Yeah. In Java? Methods. Methods and functions are the same thing. Methods are part of a class, functions are standalone. There, I probably just screwed up Howard completely, but you know, methods and functions are the same thing. It just depends where they're residing. A method outside of a class is a function. That applies to all languages, not just Java. That's why I know that. Now, in most programming languages that allow object orientation, you can overload a function. In other words, you create a function and define it elsewhere and have a different set of arguments for it. So you can have a function with 2 arguments or 3 arguments, and you choose whether or not you want to include the extra arguments. There's optional arguments. SQL is the same way. That's a magic word, guys. We've got about another 6 minutes. So you choose the bits and pieces. Today I'm going to focus on the first 3 pieces. And in actual fact, like I said, I'm going to stop halfway through this slideshow and pick up from it next week. All right, there's the 3 basic parts of a select statement. There's the field list, the table list, and the conditionals list. The field list is what bits and pieces do you want to retrieve from a given table or tables. The table list is where do you want to get the data from, and the conditionals is your filtration routine. In other words, how you don't want to retrieve all 1 million rows, you just want to retrieve 3. And you use the conditional to specify what you're trying to retrieve out of a database. Okay, the field list has 2 options, essentially. It's hard to see, but there's an asterisk on there. Select star. It says, grab all available columns from the table or table list. If you're retrieving from more than 1 table, it'll grab the columns for every table. Or you can retrieve a defined list separated by commas. Select star or select ID comma name. Now this is where I highlight the importance of selecting just the bits and pieces that you need. So let's just say we have a table with 25 fields. There's 25 fields, also known as attributes. 25 fields / attributes. Let's say 1 record. So in other words, a collection of 1 full set of 25 fields amounts to 5K. By K, I mean kilobytes. Now you guys think 5K, that's nothing, right? No problem. Say there's 10 million rows in your database. All right, I'm going to pull up my little calculator here because I can't do this math on top of my head. Okay, that's 48 megabytes. 48 megs. Doesn't sound like much, but it's still a fair amount of data. 5K is not big. 5K is maybe a handful of characters, some numbers. You also take into account that it passes along, delimiters to identify, end of field markers and stuff like that. So that's why it occupies 5K. So let's just say, in most server environments, you will retrieve often the web server and the database server, or the application server and the database server don't reside on the same machine. So you have 2 machines sitting side by side. Right? We've got the database server, then we got ourselves a web server. And let's say I did a select star, and then every single time I request the data, it pushes along 48 megabytes. Doesn't sound like much, right? Really, 48 megs? But for everybody's fancy phones nowadays, where your pictures are 4 or 5 megabytes each, you're saying, that's only 10 pictures. So it's only 10 pictures of Am I Pretty Today? I don't know, are you? but there's 48 megabytes going one way. Now imagine we're doing 1,000 requests a second at 48 megs each. Suddenly, we go from 48 megabytes to 48 gigabytes a minute. How well do you think your servers are going to cope with that much data being pushed down its pipe? Here's the catch. Most interconnects are probably gigabit Ethernet. That means they're able to push 1 gigabit theoretically every second. If we do the math, 48 divided by 8 is 4, right? No, that's wrong. 6. Dan can't math today. At most we can pass is 6 gigabit. There's a pipe issue. You're running out of room. So that means all the commands are going to slow down until all the data comes through. Now, if I were going to do a select ID and name, suddenly we could be going from 5K, roughly, numbers are all approximate here, down to maybe 200 bytes. Why? Because the ID and the name are small. One's a number and one 50 characters long. Suddenly we're down to 200 bytes with all the necessary handshakes and delivers and everything. That's supposed to be a B, by the way. My handwriting's cool. If I went instead, let's say this was 48 megabytes. This would be 1.9 megabytes. Essentially, how many of you have played with a pressure washer? It's all guys, eh? I love that. It's all guys. How many of you destroyed your deck with a pressure washer? How many of you were hated by your wife because of that? Cedar deck pressure washer, don't ever do that. It looked great when I was done for what was left of it. You can picture this the same way as how a pressure washer works, right? A pressure washer works by using a really small hole and pushing water through a really small hole really fast. Therefore, it's creating a compressed stream of water. But that hole can only let so much water go through. Pipes between computers are the same way. The pipe's only so big, you can only get so much to go through, right? Just like you pull the plug in the bathtub, the water doesn't disappear instantly. It's got to wait till everything gets through that hole. So if you're using smaller chunks of data coming out of this select statement, your commands are going to return faster. Why? Because it's not moving as much data. So in theory, if we go from 48 megabytes down to 1.9, so that means here we'd be moving maybe about a gigabyte and a half. Think about it. As opposed to 48 gigs. The pipe can cope with that no problem. Back and forth really quick. I think my math is right. It might be off a little bit, but that's pretty much how it works. So that's why it's preferable to use a list of fields as opposed to a select star. Select star is great when you are trying to find out what's in the table. Use select star to find out what's in the table. Once you know what's there, use a targeted approach. It's like video games, right? Use the Redeemer to wipe out an entire area, use the sniper rifle to get rid of an annoying guy. All right, the table list. There's 3 kinds of table lists, one of which I'll talk about today. The other ones are for further down the pipe. One's for selected from a single table. No, select star from users. you're grabbing the data, you're grabbing all columns from users. There's joins, that's when you need to pull from multiple tables. That's almost an entire lecture to itself. And then there's derived tables, that's another lecture to itself. So far I go from test. And then we've got the conditionals. Howard said by now you should know what an if statement is. Did you talk about if statements yet? Vaguely?
No, we haven't.
You have not?
Yo.
Okay, well, hey, you never know. You never know. Just because that's the plan, that's not always how it happens. Okay, so this is like an if statement, except it's called where. Where this rule is true. In other words, a series of Boolean expressions, they always evaluate to yes or no, true or false. In other words, where ID is equal to 3. Therefore, give me any records where the ID is equal to 3, where if the ID of that record is 3, then it's true. Give me that. Where the date is greater than September 1st. Therefore, look through all the data, one by one, say, is the date greater than September 1st? Yes. You can have this one. Is it greater than September 1st? No. Okay, I'm not going to show that one to you. You can have several operators. There's several operators you can use. Most of them you should have hopefully seen by now. And you can have multiple clauses, and it also supports the good old brackets. Remember Bedmas from high school? Brackets first. Algebra? You always calculate what's in the inner brackets, and you work your way up from the inner brackets out. Same way. If you have brackets to control your combinations or where clauses, I'll be spending a lot of time on this stuff next week, but I'm just getting it in your heads now. Brackets to control things. Okay. The normal set is very similar to the C language for comparison operators. Less than or equal to, greater than, not equal, good old bang equal sign. Right, that's not equal. Well, if you go on the internet and you look for examples for SQL, often you'll say somewhere where something is not equal to, you'll see the old style operators. Not equal was brought in fairly recently, like around 2009. Some of us that have been using it since before that tend to use the old syntax for not equals to. It's called the diamond operator. It's neither greater than nor smaller than, because it's possible for something to be greater and smaller at the same time. Thus, that was how we used to say not equal to. As the database servers now accept this, they're both valid. This is the old syntax, so if you go looking online, you'll see examples of this. Why? Because it works. And people that are past certain age of atrophy will have a hard time going to this. It's whatever you learn, right? First, tends to stick. This is known as the diamond operator, not equal to. There are some special comparison operators. There's the in a list. It looks like this. You give it a list, in this list. You have a between, in other words, between this value and that value. You've got the is. In other words, you can check if something's null or if it's Boolean. For example, you can't check to see if something is equal to null. Anyone want to tell me why you can't check if something is equal to null?
There's nothing there.
There's nothing there. So therefore you're saying, is this equal to nothing? Actually, I gotta be careful, I can't use the word is. Is. Yeah. If A equal null, right, it doesn't work because something cannot be equal to null. Either it is or it is not. Therefore you can say, is null, is not null. So you can check to see if a field is null, m/empty, by doing an is. You can also check to see if something is true or is not true. Technically, you can go where active equal true, but it's better to say active is true or is false. For two reasons. One, it's easier to read. Two, is tends to be a Boolean operator by default. Is it or is it not? And then you've got not, which basically modifies the other three, right? Is not in this list, ID not in this list, ID not between this, or ID is not null. So those are the magic operators. Essentially, what's going to happen is next week it's basically going to be a demo day. I'm going to cover a lot of the basic parts of SQL, sitting here typing, and we'll actually have that screen up here so I can actually not make so many typos. And then I'll finish off the rest of the slideshow. Other than that, it's too late to put in the attendance, so if you didn't do it, you're not here. It's just me keeping track for administrative purposes. Once again, don't forget this stuff. It's important. You don't get it done, you don't get the points and all that stuff. Other than that, I'm going to call it quits for now. That's enough for now.